Thanks for coming and showing up early in the morning. This hopefully is an interactive panel. We're here to talk about DeepIn. I think it's one of the most exciting, if not the most exciting category in crypto, because the problem that we have as an industry is that beyond speculation, none of this is really relatable for businesses or for real people in the real world. And DeepIn really achieves that. So we have one of the best DeepIn projects upstage. I've had the privilege of knowing most of them as they built their project. So why don't we go around and you guys describe what your individual project is doing, what kind of problem you're solving in the real world. Why don't we start with you?
Yeah. I'm Abhay Kumar. I run the protocol at Helium. I've been part of the project since 2020 when I started by deploying my first hotspot. So Helium is the world's largest decentralized wireless network. We have been building two kinds of networks over the past several years: an IoT network that supports things like package tracking applications and water leak detections and other kinds of sort of small messages that are being sent over the air. And then more recently, we've been supporting a wireless network for phones. And so my favorite thing to do these days is I sell free phone plans for people in the United States.
Okay.
Great. My name is David Chen. I'm a co-founder and also head of a blockchain in GEODNET. So GEODNET is the world's largest RTK network. So I guess a lot of you may not know what RTK means. So in a single word, RTK means we provide 100 times more precise positioning services than regular GPS. So imagine GPS can deliver accuracy between 1 meter to 5 meters. But with GeoNet RTK network, you can receive the accuracy of about centimeter. So it's like this big. So that will certainly enable a lot of applications like autonomous driving, drone operating, and particularly we have a really high flagship business partner, United States Department of Agriculture. They will utilize our precise positioning service for farmers and reduce their cost.
Awesome. I'm also in Federa. I'm one of the 3 co-founders of the DoubleZero protocol. We are a little bit different than most crypto projects. We're a physical fiber infrastructure network for high-performance distributed systems. So we're talking about literally physical fiber cables in the ground and really building a parallel pathway for high-performance distributed systems to the public internet.
Right. A lot of the controversy, I guess, in DeepIn is like people don't really appreciate how hard deploying infrastructure is. And the natural skepticism is like, well, why do we need crypto? Like, what exactly does crypto uniquely enable? And how does that actually translate to the end user? Like, are you lowering costs? Is the CapEx requirements lower? Are you sharing that across the network? Like, why don't we start with Helium? Because, for context, you guys have been working in the US. You've deployed, 98,000 hotspots now. You have IoT devices all over the world. And most recently, 2 of the 3 largest carriers in the US started using the Helium network. So walk us through like that conversation with AT&T, which you announced recently. Like, what did they see in the Helium network that was so valuable for them?
Yeah, I mean, there's some interesting stakeholders that we work with, and AT&T is one of our customers or one of the network's customers now. So we have folks deploying hotspots in small businesses, near parks and malls, all over the U.S. And these are places where some of these carriers have trouble providing better connectivity for their own users. And this really comes down to fundamentally a physics problem. So to deploy 5G, which is sort of a higher bandwidth but and lower latency network, you need to have a lot more density. And one of the problems that carriers have is making sure that all these devices that need to be deployed at such high densities have someone actually managing them. So what Helium does is that it sort of hands off that responsibility to the end user, the end deployer. So this could be a coffee shop owner, a mall operator, a service provider at a hotel that's actually installing hundreds of wireless APs around the property. These are the kinds of folks who are very directly, they want to serve the customers that are coming in and out the door. And then AT&T has no real way to sort of reach all of these at scale. So they work with us to be able to access this large network. And then they're able to they get two things out of this. One, they get significantly lower costs. There's no capex, right, to ask somebody else to deploy, and then they get better service for their customers. That's actually what they truly care about. Their subscribers have demands of their, of these networks, and they're able to fulfill that. So that's what someone like AT&T or others see in a network like Helium. This is called the offload business, if folks are familiar in telco. And then, this is one way that they're able to do network planning. And the Helium network are able to sort of support these kinds of partners in other ways as well. AT&T and other telcos need to understand where these radios are, like what is the backhaul, what is the quality that these subscribers they should be expecting when they're attaching to these radios. And that's something that is sort of a derivative data set that we can build with this sort of massively deployed network that allows these carriers to select, well, when this subscriber is in this region, you should connect to these hotspots preferentially, rather than using the larger macro AT&T network. So these are for two different ways the Helium network supports them.
So concretely, if you have any business, if you have an apartment or home or your business, you say, I'm going to connect a hotspot, and it's really cheap. It's $200 to $300. It's like commodity hardware. You're going to participate in this network because you have wireless that you're not using. So you're provisioning some of that excess capacity to what is called a Helium network.
Yep.
And then if you're a mobile user walking through that area where you have coverage, AT&T might own that relationship, but it's cheaper for them to offload that data to that user.
And just to put a real number on it, a couple of weekends ago, 900,000 phones connected to the Helium network, and they had no idea they were using a crypto-powered network.
Yeah, and the nice thing is these users don't know what's
idea.
happening in the back. It's sort of invisible, right?
Correct. The phone doesn't need to be configured in a specific way. Their SIM that's already on the phone is able to authenticate to any of these Helium hotspots and just automatically attach.
Yeah. And just to round out this point, it's like the reason why it's cheaper is because wireless, like Wi-Fi, is just cheaper than buying that gigabyte capacity from a cellular tower.
That's right.
Okay, great. Because telco is like one of those areas where not a lot of people understand, but everyone uses, right?
Right. Of course.
Mike, let's talk about GeoNet. Like you talk about like GPS being very not precise and what you guys are doing. When I first met you guys, it was one of those rare projects where you were getting more interest and traction outside of crypto from real users, farmers, drone operators, now the Department of Agriculture. Walk us through kind of like what concretely did they see in GeoNet that they were not able to get from sort of the competitors in the real, Trimble and Hexagon.
Yeah, so we are in a very good spot. So GeoNet tried to solve the problem that provide, a widely available precision network. Traditionally, in this space, there are already multiple players. Trimble is the largest one in the United States, and Hexagon is the largest one in Europe. They are public companies, their market value about multiple billion. So what they do is they slowly, deploy base stations, and based on, their capex and their resource, and try to cover the region slowly. For the last decade or 20 years, they reach a network coverage about 5,000 base stations. And for us, we do it differently. We utilize the blockchain mechanics. We're using token to incentivize, and we've been growing to 16,000 base stations within 3 years. So that's like 3 times bigger than any Web2 competitors. You might consider they are public company. They have a market cap about 2 billion USD. So we are a start from zero using blockchain and create a network 3 times as big as they do. And on the other side, even we are young, we are 3 years blockchain project, we are already produce almost 4 million revenue annually. That's pure data sales, not from hardware. And we will continue to grow to 10 million very soon. So some of our customers are from traditional, right now, most of the paid customers from traditional Web2 businesses. One example is the USDA. So basically, we will, a lot of the farmers in the Central Valley United States, Europe, they are already operating unmanned tractors. The tractors, moving around the farm field 24 hours, 7 days, but they do require precise positioning service. So regular GPS won't help, because if your tractor driving accuracy is bigger than 10 centimeters, it will ruin your crops and reduce the yield of your farm field. So you really need RTK service. And they typically pay like about 1,000 to 1,500 USD a year subscription per device paid to the Trimble or other providers. And for us, because we can build the network in such a low way with blockchain enabled, we will charge maybe 1/10 of the cost, or even sometimes like 1/10 of the cost. So USDA really liked the idea because we help the farmers to reduce their costs. So they want to partner with us. They buy data from us, and then give away free for the farmers to use. So really, the GeoDNet is a very good showcase in deep in space that we can do something really good using blockchain technology and also bring real revenue into the system.
So concretely, you can produce a network that can deliver really precise location data for farmers or even gaming companies that want to have like Pokemon Go style, like
Exactly.
precise, because GPS is not precise. If you're going to buy this data set, you can provide it cheaper relative to the competitor in the Web2 world. Because when you say you're leveraging blockchain, it's like you're convincing people that have already the location to deploy the station. And you don't have to get a lease. You don't have to, that's a really expensive part in the normal world that you guys are kind of leapfrogging. So
Yeah, just some quick notion. So we are utilize existing rooftop real estate. So if you own a home, you have a roof, a clear roof, and then you have internet connection, you can provide power. You can be one of our miners. So you set up base station and set you up there and provide precise location to real usage, and you earn passive income.
Austin, I want to turn to you because I think you have one of the most ambitious, fascinating projects to come out of crypto in the last couple of years. You were previously at Solana. One of your colleagues, Ben, who I think you spent a lot of time with, when you were starting to think about Layer Zero, I think it was last year, I first heard about it. He said, Austin is like the network guy. He would go into every Solana office and he loves wiring. That's like he lives and breathes this stuff. What did you see? I mean, like, please, like, walk us through kind of the opportunity that you saw. Why did anyone like before you didn't think about this or see it?
Yeah, I mean, this is your original question was, why does this thing need crypto, right? And the answer is because we've seen people build it otherwise, and it just doesn't work. The internet that we have today is what DoubleZero would look like without blockchain applied to it. And the internet today is great for a lot of things, but it's built for really incredible reach. You can reach any server anywhere in the world from pretty much anywhere else in the world. But the thing that you can't do on the internet is high performance, right? This is why every single traditional financial firm uses dedicated private fiber or shortwave or microwave towers for trade execution. It's why Google and Amazon and Facebook are investing billions and billions of dollars to run fiber around the world. And you kind of like almost every large software company eventually gets to a place where it has to look at hardware and it has to look at connectivity. I mean, Facebook famously wired up the Philippines, not out of the goodness of their heart, but so they could sell ads to more people. Like the internet infrastructure in developing countries was the limiting factor for them in expanding their TAM. And we're at that place with blockchain now. And so yeah, you could come in and say like, oh, well, we already have Jump Trading and Citadel and many of these companies. I'm sure most of you have read Flash Boys that run private fiber all around the world, and they do this. But you have to think about this in the traditional financial space. It's a very tractable problem with known endpoints. I got to get from the Chicago Mercantile Exchange to the New York Stock Exchange. Those two things don't move. That is not the case in crypto, right? You look at a network like Solana, there's 2,000 nodes around the world. They're moving around all the time as they try and optimize 10 basis points of additional MEV or block rewards. You look at these next generation blockchains that are coming up, and they might not have 2,000 validators, but they've got 200 validators, and those also move all around the world. Plus, you add the problem of RPC servers on top of it, And what you end up with is a network that's too big for any one firm to build itself. At the same time, if you resort to the public internet and the economics of how things work on the public internet today, you don't get high performance systems. You get high reach systems, but low performance systems. And so what we're doing with DoubleZero is allowing anyone who runs a private fiber network to contribute a graph of that network, be it individual links or a whole collection of links, and to devices operating on it, like validators or other high-performance systems, it really appears as if it's one homogeneous network, the same way you would expect if you were, a Google engineer working on Google's private network. The difference, though, is under the hood, it's run by multiple independent contributors. And if we didn't have that, if we just went out and raised, $1 billion and built a fiber network ourselves, right, no one should trust us, right? Because we would have all the admin keys, we'd be able to censor the network. But by having multiple independent contributors and multiple independent fiber providers involved, you actually provide resiliency that approaches that of the public internet. And you really can't do this without tokens. Like, tokens are an alignment superpower. It allows people to say, okay, I have a 400 gigabit link here. I'm going to carve out 100 gigabits and contribute that to the DoubleZero project and earn some tokens in exchange for that. And we're able to do this in a way that really hasn't been possible before, because all this networking technology, we're using like basically off-the-shelf networking technology. The difference is we've built in all these components that allow it to be decentralized. You reach consensus around proposed routes and all these things that you need if it's going to actually be trusted by blockchain.
I want to double click on, like, for folks in the audience, like, what does that actually mean for if you're like a blockchain project? Because you're just a bit more detached from the end user. I feel like
Yeah,
your
definitely.
customer is like any layer one, layer two kind of infrastructure provider in crypto, like a chain would use DoubleZero to get faster, like, execute.
Yeah, exactly. So end users, right? It's sort of like, who are the customers for RPCs? Or, like Infura doesn't sell to end users. They sell to wallets and applications and those sorts of things. So for us, we're not even providing a compute layer. It's bring your own server, bring your own bare metal provider. It's just the data connectivity layer between these systems. And so there can be situations where, an L2 that has a single sequencer team decides, hey, we want to operate this single sequencer on DoubleZero, because even though it's all one server and you'd think that network connectivity would not be the limiting factor on a single server, it actually is, because you've got to propagate data out to the entire RPC layer. It doesn't matter if you're moving, blocks at 10 milliseconds. If you can't communicate that out, if your light cone propagation delay, for lack of a better term, is slow, the network is basically not moving that quickly. Like, no one looks at the New York Stock Exchange and goes, well, what's the execution trade time on the centralized exchange? I mean, it's so fast, no one cares.
Right.
The question everyone fights about is how quickly can we get new, fresh data into our trading systems to be able to make use of market arbitrage or market movement data. And we see this in crypto, right? If you look at, like, Solana built a validator client that can do 1 million transactions per second. Aptos has benchmarked their validator client to, I think, somewhere around 700,000 transactions per second. Sui's in a similar place. You see similar numbers coming out of Monad and Mega ETH. And then you get to prod, and we're like 100th of that at best. And some of that is mainnet load is different and mainnet programs have different requirements. But a bunch of this is the public internet. Like, we've got a bunch of Ferraris stuck in traffic, as you all see every day when you leave this building. There's a lot of nice cars stuck in traffic here. And that's the limiting factor nowadays. And so if we can build better connectivity between these systems, we can actually move blockchain forward by a decade or more, not by changing the underlying code, not by doing massive changes to how protocols are written, but just giving them more dependable, higher quality connections to run on. And that's the entire point of increased bandwidth, reduced latency.
Yeah, I was going to turn to that. Obviously, you come from Solana. Their whole MO is, hey, we want to be NASDAQ on the blockchain. We want to, increase bandwidth, reduce latency. What would, like, if in a scenario where, fast forward 1 or 2 years from now, you guys are at, delivered on your timeline and on your vision, what does this mean for a network like Solana?
I mean, Solana for a long time was software limited, right? It was the validator client that was holding it back, and now it's the hardware connectivity that's holding it back. There's 2 incredible independent software clients on Solana, the Agave client by Anza and the Firedancer client by Jump Crypto. And I think you see this across the board now, is that for years, the software was too slow. If you ran Geth locally, it would max out at 400 TPS. Like, you just couldn't get that system faster. That's not the limiting factor anymore. So if we are successful in our endeavor in 2 years, it's the software guy's fault again.
I don't think you can do like multiple concurrent proposers without something like DoubleZero, right? Like I think it's actually impossible.
Yeah, I mean, we
So
can
like
get in.
Solana's future roadmap, I think, is actually limited on the network layer.
Yeah, I mean, this is the whole thing with we can. I know
Yeah.
this isn't the super technical panel, but like multicast is a technology that you cannot run on the public internet, and multicast is a technology where so right now, if you use Solana or Monad, they basically have erasure coding of Merkle trees for state propagation, and that is Turbine and RaptorCast. And so what's happening is one validator is sending out a bunch of data to 200 nodes, and they're sending out to 200 more, and they're sending it out to 200 more. It takes a ton of bandwidth. But it's the best you can do in a unicast world where validators operate over the internet. The way this works in a high-frequency trading firm, or the way this works in a proper data network, is you use multicast. And multicast is basically hardware acceleration of packet replication. So one packet goes out from the server, the network switch makes, 40 copies of it and sends it on to all the places it's supposed to go. And because multicast replicates data the furthest from the core possible, always at the edge, if you have to take, like block propagation data from a validator, here in the UAE and move it back to New York, and there's 1,000 validators in New York, right now there's 1,000 copies of that data running across the Atlantic. With multicast, there's only 2 copies of that data moving across the Atlantic. So it's much more efficient and it allows these systems to move much more quickly.
We got roughly 13 minutes left. We've painted the great grand vision for Deepin in respective kind of industries and the impact. There's still a lot of criticism out there within crypto, certainly maybe outside of crypto, maybe less outside of crypto actually, because you go to a customer and you say, listen, we're going to lower your infrastructure bill, or we're going to provide a faster service, which is really exciting, I find. Let's double click on like the criticism of Deepin, like in terms of, can this actually scale? You hear that a lot. You hear, well, the tokenomics are broken. It's never going to work. Like, this is too good to be true. It only works in a small scale. So, like, let's maybe in your respective projects, tell us like what is the bear case, or what is the common criticism that you hear, maybe within crypto, or more interestingly, as you face the real world and customers like AT&T. I appreciate might have taken many years where they were looking at your reliability for offloading and some of the metrics. Like, you're pioneering some really cool stuff.
Yep.
But let's like flip it around. So, okay, what are the common criticisms? What are the challenges that still need to be resolved as you go and really scale these networks?
I mean, I think a lot of people that know me personally know that I'm a perma bear, so I'm always a bear. But I guess, like the way that I look at it is that crypto UX continues to be impossible. And we just see it like, was a couple of days ago, someone lost a crap ton of Bitcoin out of a wallet that they hadn't touched in years. And like, that is terrifying. Like truly terrifying stuff. And the fact that like 12 words that you take a picture of and you shove it on iCloud is at risk, or you put it in a password manager is at risk, like that is all terrifying stuff. And those are, I think, the really like the near-term issues, which is actually why Helium Mobile, our consumer subscriber business, has no crypto on the front end. You don't see it at all. The business is like, we are a crypto enabled product. Right, the business works. MVNOs traditionally are very thin margin businesses. They're not like there hasn't been a lot of disruption in them. Like, unless you have someone ridiculously attractive as your spokesperson, like Met does. I'm not that person. So instead, we just have very cheap wholesale rates for data, and that enables us to offer a free phone plan, or offer a $15 phone plan, or a $30 phone plan, depending on the kind of plan that you want. And that's ultimately, I think, yes, the bear case of crypto is that it will remain too complicated for the average user to use. And so it's kind of incumbent on product teams, and certainly the take that we have, that just hide it and allow your business to be enabled by it, but then be able to offer that, 10x cheaper or 10x faster product to the consumers that care about it.
So it's mostly on the front facing side for.
Yep. And we think we've sort of taken the kind of strategic product decision that we want to hide it as much as possible. And obviously, if someone wants to get in there and try to understand why are you able to offer a free phone plan, oh, it's because when you are a subscriber, you're sharing your location data to the network in an anonymous way that is privacy preserving, and that helps build the network. It tells us where there is demand, and we have a tool for AT&T to then go say, oh, there, or to a deployer to say that this is where there needs to be a hotspot deployed. Right? We have this observed demand tool. We have these quality of service metrics tools, and these are the things in the back end that are it's a virtuous cycle. A person who signs up for a free phone plan isn't just freeloading; they are actually providing value to the network.
Great. What about GEODNET?
Yeah, I want to give some feedback on to the critics about dipping project. So I think dipping is slightly different than the other crypto project. So the physical infrastructure typically need time to build up. Let's compare to the Web2 approach, right? If you're talking about some infrastructure, it literally take maybe decades for the infrastructure to reach some degree of level. So dipping using a different way, it will dramatically increase the deploy speed at a much lower cost, but still you need a time to build up the infrastructure. And the second, if you want to get actual revenue that make real business want to pay for your infrastructure, your infrastructure either decentralized or centralized, you need to reach certain level of availability, performance that take time to build. So as a GEODNET example, we've been in this space for 3 years. So it takes us like the first year just purely build up the infrastructure without any income. But again, once you reach a certain level, like we are right now, we can provide the same commercial grade as the traditional Web2 provider. But that's not easy. So to reach this stage, a lot of work to allocate between Web2 and Web3, but it works. So for now, as I said earlier, we are almost having 3.5 up to 4 million revenue annually, and it will continue growth. So the dipping is something working. You bring the real value into the system, and you actually make real use case.
But like let's just like on the bear case, like if you're a Tesla, you need really precise data for self-driving. If you're a farmer and you have an autonomous tractor for farming and great efficiencies, you need really centimeter grade precision that you guys can provide. But there's alternative solutions. Now you're saying the data set for where you guys are able to undercut them, so it's cheaper. But why might Tesla or a farmer or Niantic who develop Pokemon Go, like why would these guys look at you and say, you know what, we're not going to use you. We're willing to pay the Trimble and Hexagon more because for some different reason. Like why?
Yes, so I think the price certainly a very big impact because we cost maybe 1/5 the cost. Even consumer product, we can even reduce even more. And the second is coverage. So we have 16,000 nodes all over the world, and it cover a lot of areas that traditional, Trimble, Hexagon, they never have coverage. For example, in India, we are the only commercial available network there. We have about more than 500 base stations right now. The next one is their government-run, really old style, which cannot meet the modern use cases. And we have coverage in Southeast Asia. And we start to build up coverage in Latin America, South America, like Brazil. It grows very fast. And we even have more coverage in Africa, so South Africa. So we are thinking, as the robots become a really, emerging technology, and imagine all the outdoor robots, they need a precise location, and they need us. The traditional Web2 customer, they are very focused on certain areas, like, provide service for ag, for survey. But for us, we are open. It's an open platform. It's a much bigger coverage, much lower cost, can power a lot of more applications, not just Web2, but also Web3, like Pokemon Go. We provide a precise service for gaming and virtual reality. A lot of things you can imagine.
Yeah. Austin, you're earlier in the journey. what are you mostly focused on in terms of like the key risks for really scaling out and executing like the next 1 to 2 years?
The biggest risk for DoubleZero is the ambition of this space is still pretty small. People are happy about 10,000 transactions per second. They're celebrating L2s that are hitting 1,000 TPS. Like, if that's the end, then like, I don't know if you need DoubleZero that much, right? At the end of the day, like, we're building for a world where you have multiple chains running hundreds of thousands and millions of transactions per second. And that's kind of the world that we need and want to see built up if we're going to find that hardcore product market fit just in crypto. I mean, we can support all sorts of, I mean, you know, as I said, high performance distributed systems. There's lots of things that are not crypto that also fit into the needs of what DoubleZero is building towards. But the main one for crypto in this space is just our aspirations and ambitions are still pretty small, right? It's like the best thing that can happen in this industry is Bitcoin hits 120, and it's like, that's great. Price is nice. We all like price. But at the end of the day, like, when you 10x or 100x or 1000x capacity, you get to see different types of applications built that aren't possible before. And like, the traditional tech industry knows this very well, right? You launch the iPhone, it's kind of a flop. You launch the 3G iPhone, suddenly people see like, oh, we can actually do different types of things in this mobile experience, and it changes taxis forever, and it changes his dating forever. Like, things that I don't think Steve Jobs ever had in his mind when he launched the iPhone. But like, the idea behind that is it wasn't that we had a smartphone suddenly. We'd had, Blackberries and Palm Pilots for years. It was that we had fast mobile connectivity that actually made it possible to build entirely different types of experiences on it. And so people will ask me all the time, like, what do we need 4 chains that can do 1 million transactions per second for? And I have no clue. But like, if you ask someone in 1994, what do we need a gigabit internet connections at home for? I don't think they would have had a lot of good answers either.
Yeah.
And so really it's about creating more new greenfield space for people to build interesting things in.
Like on that point, like the arc of technology is usually like the smartphone, for instance. It came out, it was like like it was a great form factor, but connectivity was like very expensive and very slow.
Yeah.
But it was such a killer product that it justified capex investment to deploying a network, and then you had more apps, and then it just kind of like that flywheel. Progressively, like you stress test the infra, you justify more capex because there's underlying like products. It was Uber or Netflix, and like mobile just became such a powerful thing. When you talk about the problem as an industry, we have sort of a lot of times we hear there's too many L1s, there's too many L2s, there's too much infra, not enough, real connectivity and products. What's your vision like? Like, why is that? And is it like that because like if you're a developer in the real world, you say, God, these blockchains are like terrible. I'm not going to go into crypto to build something that I think requires way more TPS. So why bother? And like, why build it now? You know what I mean? Like, why hasn't anyone like, why does it take someone like you at this
Yeah.
moment? We've been here for 12 years and no one has said, gosh, I want to build, DoubleZero.
So a few things. One is it's expensive. Like, physical fiber infrastructure is expensive, and you need networks that have actually fee generating applications on them to make it worthwhile, right? The other thing is blockchains and centralized exchanges were slow for a very long time. Matteo, my co-founder, actually sort of tried to build this back in 2017. He never like launched a company for it, but he was like a hardcore networking guy who'd been working with a lot of companies and TradFi space on like wireless links between exchanges so you could have arbitrage opportunities. And he was like, crypto needs this. It's insane that everyone's just running this stuff on residential internet connections. It's like, yeah, but Ethereum does 14 things per second. There's 30-second block times, and 98% of that time is just for networking. Like, people weren't building systems yet. And crypto is great at so many things, but like, we reinvent the wheel again and again on basic things that other industries have figured out. And one of those is like speed matters. And if you want to compete with centralized systems, it's not good enough to just be like, oh, but we're more decentralized, right? You have to actually be as performant or more performant. And so that's one of the main reasons. The other thing too is the global fiber network is bigger than it was a few years ago. There's some other macroeconomic changes that have sort of happened that have increased access in those areas. But really what it is like we got a bunch of developers in building high performance validator clients, and they need a network like this now, and they just didn't need a network like this in 2017. There's still no use for Bitcoin on DoubleZero. It's not what Bitcoin is trying to do.
Right. Maybe as the last question, in a world where this truly works, like what does that actually mean for all the L1s that, every L1 is manufacturing the highest TPS and the best metrics?
Yeah.
Like you come along, like what does this mean? Like, do you just commoditize the entire L1, L2 layers? Like,
So I think the place we get to pretty quickly is very similar to like the cloud providers, right? Where we have 4 to 6, depending how you count, pretty high quality cloud providers that all offer fairly similar generic services, but there's different modules and different components that they add that like makes a company pick one over the other. At the same time, we have people who run across multiple different cloud providers in the Web2 space now. And so I think we'll get into a situation where the differentiation between individual L1s may be less. And it's more about the ecosystem and the applications built on top of them. That complete feature set where you're picking, do I want to stick in the Ethereum world? Do I want to be in the Solana world? Do I want to be in someone else's world? A lot of that will be determined by not what can the L1 do, but who else has chosen to build in that business environment.
great. Gents, thanks so much for the time. It's a really good discussion.
Thank you.
Great. Thank you.
Thanks.